Okay, here we have another algebraic expression, and I'm going to demonstrate how to use the distributive property of multiplication by writing that expression another way. I'm going to use what I know about the distributive property to do this, and considering the structure of the problem, whereby I have three terms that I'm adding together, I'm going to kind of rework that structure somewhat so that I can write it a different way using the distributive property. The first thing I want to do whenever I see three terms and it's written like this and I want to write it a different way, I automatically think, what is the greatest common factor of these three terms? What can I pull out of all three terms that they have in common? And when I look at this, when I look at my coefficients, I'll look at those first. I have 36, 7, and 5. Now I know that they don't have any factors in common at all except for one. Those three coefficients are all what we call relatively prime. The only common factor they have in common is 1. Now if it was 35, 7, and 5, then oh yeah, that would be great because, well, still it wouldn't, because three terms it wouldn't work. I mean, it just wouldn't work. They don't have anything in common. Alright, let's look at the variables that they have. I see here they have s squared and t squared. Here they have st, and here they have st. So while they do not have any coefficients that share common factors, they do have variables that they have in common. They all have at least one s and one t. So if I were to write this one out a different way using the distributive property, I would put st outside, and in parentheses, I would go ahead and put 36. But now, what do I multiply st by to get s squared and t squared? What am I going to have to write next to 36? What do I multiply by s to square it? What do I multiply by t to square it? I have to multiply another s and another t with it. Yeah. So I'm going to go ahead and say st here. Then I have st here. What do I multiply it by? I'm going to make that look more like a t. What do I multiply this by in order to get 7st? Just 7. I'm not going to say st because if I do that, I'd wind up with 7s squared t squared. Let's go ahead and look at the next one. Here I have 5st. What am I going to multiply st by to get 5st here? 5. We'll multiply it by 5, just 5. Now to prove that that is correct, I'll go ahead and I'll multiply each of these terms by st. So 36st times st is going to give me 36s squared t squared. Plus st times 7, that's going to give me 7st. And st times 5 is going to give me 5st. Okay, so I wound up taking these terms. I found the greatest common factor, which was st. I took it out, and then I just put the terms in here that would multiply by st in order to get the original expression that way. So, how many of you, my little students, got the same thing I got? You put st outside the parentheses, and inside parentheses, you said 36st plus 7 plus 5, close parentheses. Okay, alright, now how many of you understand it better now? Okay, I'm glad that this was effective to demonstrate this for you all. Now, using our SFA rubric, what grade will I deserve, children? 100. Yeah, I told you my math practice before I even really got started trying to solve it. I showed you my process, I showed you the correct answer, and there you go. Alright, thanks for helping me out.